Unifly. Here you go, sir.
So this is forward.
Yeah, the green.
Good morning, everyone. And the exact pronunciation of my name is Kegelaers. I forgive you. It's impossible to pronounce for everyone that's not Belgian. Cool. I'll start with mentioning a few things about Unifly because a lot of people probably don't know yet what Unifly is. Well, we are a developer of UTM technology. We've heard a lot about UTM. Well, we are the company that develops the technology to make UTM a reality. We started to develop our prototype in 2012 already. So we've been at it for about 7 years now. And the idea of UTM, of what we're trying to do, started in the heads of 2 military air traffic controllers. They saw low-flying jets and low-flying helicopters, and all of a sudden, there were some drones flying in the vicinity. They said, well, we have to solve this, and you cannot solve that with standard ATM. So they said, we need to create something that is specific for drones. We are based in Belgium. That's where the head office is. We are at the airport, the International Airport of Antwerp. We also have a subsidiary in Denmark. Some of you have met Ronnie Östergaard yesterday. We also have a subsidiary in the United States where we have been doing some work. For instance, we are alliance compliant. The way that we position ourselves as a company, we want to be are the partner of air navigation service providers, CAAs, and local authorities to give them the technology to be able to integrate the drones safely into the airspace. And this is no pie in the sky. This is something that we have been doing for a while, and we actually have 4 implementations already at a national scale. The most advanced probably is Skies, and the way that we implement our software is on a phase-by-phase basis. You can start very simple and then go all the way to a complete system. The most advanced one is Skies. It is such that in Belgium, my home country, all commercial drone pilots and their drones need to be registered in a central system. Each time that they want to fly a commercial flight, they go to the system using a web application or a standard phone application. They verify if they can fly somewhere, yay or nay. And very often they find that they have to ask for approval, hit a button, the flight approval gets sent to and the CAA and the ANSP. Once they both approve the flight, then the flight can happen. So that's what the situation is today. Has done wonders for the industry, whereas it took in the past up to 6 weeks to get a flight approval. Now we've seen that it is actually within a day that they can get flight approvals. The other big implementation is the Deutsche Flugsicherung. That's a very, very complex country. You have 1 ANSP and 18 Bundesländer, so 18 states if you want, and each state have their own drone regulation. So it makes it very, very complex to operate. And then we have Naviair in Denmark and Oslo Control who are also using some of our technology. Those are actual customers. Now we've also heard a lot about U-Space, the fact that the European Commission is pushing forward on creating this U-Space concept to enable the drone market in Europe. And they've thrown quite a bit of money at this. They've had a number of research programs done. They've had a number of demonstration programs done. Now we are involved in 10 of these programs, and by that, we are probably the largest contributor to the creation of this U-Space concept. Without going too much in detail, I'll just mention a few of these projects because they're so interesting. The very top one is a Chorus project, and that's the concept of operation of a European UTM system. And that really is us working together with a number of ANSPs, a number of companies, to try and define how do you operate drones in Europe in such a way that the services that you offer in Norway are similar to what is offered in Germany, is similar to what is offered in Greece, so that you could actually operate your drone and your company anywhere in Europe. Very interesting document. The results are free of charge. You can go to the website of the EU and download that information. The other project is Podium, a very, very large demonstrator where it's about 180 flights were done in 5 airports in 4 countries, all with the same concept. But the one that I'm most proud about is probably the Sapphire project for a number of reasons. First of all, we were the lead in that project. But it's probably one of the most complex demonstrations that have happened anywhere in the world so far. We had a national authority, the CAA. We had Skies of Belgium. They were using our UTM platform. We had the local authority, the port commander of the Port of Antwerp, who was involved in flight planning process, in flight approval processes. We had 12 simultaneous drone flights happening. And we had Amazon as one of them. Amazon have their own UTM system, was connected to our system. And most of the flights happened over an operational harbor, the Port of Antwerp. Most of the flights also passed over the city of Antwerp in the extended center line of an international airport. And all of that was coordinated through our system. So that's one that we are extremely proud of. Now, the question. How can a UTM system create more business for the unmanned industry? Rone Østergaard, our general manager of Unifly in Denmark, called me on Sunday. Marc, you need to give a presentation on Tuesday, and this is the question. Okay. A challenge. The good thing about questions like this is it makes you think, what really is happening. I rephrased the question. I said, why aren't we making more money? You see presentation after presentation after presentation, and you see report after report after report that the drone business is going to explode, and there are going to be hundreds and thousands of drones in the market, and the drone operators are going to be very rich people. They're going to earn mountains of gold. I see here people laughing. So it's not happening, is it? So why is it not happening? Why is this promising market not delivering yet what we are all hoping for? Well, simple question, simple answer. I came up with one word: anxiety. A lot of people get very nervous when the drone passes in their vicinity. And that's the problem. And that really is a problem that needs to be solved and where we can contribute. A drone! These are the people that become very nervous. Within the world of manned aviation, you have airports, air traffic controllers, and pilots. They get very nervous that there's a drone in their vicinity. Well, not because there's a drone in their vicinity, there's a drone in their vicinity that they don't know anything about. That is a problem. An unknown drone of which they don't know what it's going to do. Local governments become very, very nervous. Why is this drone flying over this school? Why is this drone flying over this national park? Why is this drone flying over this hospital? Do we really want that? Law enforcement agencies, lots of examples of things happening with drones that are not that kosher or not that good. So law enforcement agencies also are not very happy. And the public, what if there's a drone hovering over my garden? Do I really want that? So there's a lot of anxiety, and typically the questions that people ask is, why is this drone here? What are the intentions? Who is the owner? Is this a legal drone? Is he allowed to be here? What if he's going to hit someone? Where is it? So there's a lot of anxiety in the market, in the general public, which refrains us from creating the market. Now, in order to answer all of these questions, a lot of functionality needs to be built. And some of the things are geo-awareness. The governments, the ANSPs and CAAs have a task. They have to tell the drone community where they can fly, yes or no. There should be a form of registration of the drone pilots and the operators, so that at least when the drone passes by, that you can identify who it is. You all drive cars, you all have a license plate. We need a license plate. We need remote identification and e-identification. Well, if you have a car and you see a car passing by, you can see the license plate. If a drone passes by, you don't see the license plate. But we need to have a means of identifying who that drone is. Geo-awareness, registration, and remote identifications, those are the three elements that have now been written into European law. June 11, 2019 is a very important date. A new European law has been voted, and those are the three requirements that have come into place. So as of June next year, we should start to see implementation of that. Another function that you want, and this is typically asked by local authorities, dynamic airspace management. NOTAMs is one thing. Manual map manager, what is that? Suppose that I'm the mayor of a town, and I know there's a big concert tomorrow, and I expect 1,000 people. Maybe I don't want to have drones flying over that area. Maybe I would like to have some form of map management. Flight planning. The anxiety, let's say all the people that are anxious, they really want to know what are the intents, what is the intent of that drone operator. That means that you need to be able to give the drone operators the necessary tools to plan their flight and state their intentions and notify, I'm starting to fly. So flight planning means also multi-level flight approval processes. We've seen situations where in some locations, specifically in Germany, in order to fly a certain trajectory, you need to have flight approval of 4 different entities. And the flight can only happen after all of those entities have given the green light. How do you do that as a drone operator? Well, ideally you would give, well, the NSP should give the tools to do that. We want to have flight tracking. So once you've entered your flight planning, your flight path, you really want to know where are you flying and are you in compliance with that track. Ideally, specifically air traffic controllers, but also the local authorities, we really would like to know where the drones are, so they would like to be able to visualize that. Then we go to strategic and tactical conflict detection. That's when you start to have more and more operations. And then I'll go to the bottom section, integration with ATM using SIM. Ideally, you would like to be able to do some deconfliction with manned aviation. Integration with counter-UAS, and incident reporting and flight repair, all functions that ideally you would like if you want to reassure the general public that drone flying is safe. I wouldn't be telling you all of this if we hadn't made this up yet. So this is typically a very high-level construct of what we are doing as a company. Typically the blue boxes, top box, UTM, FIMS, USS, terms that you probably have heard in the presentations. That's typically the core of our product. Big database, cloud technology. We take in a bunch of information from the top right, AIXM or ATM, that's the structure of the airspace as used by manned aviation. So that's something that we have in the database so that you know as a drone operator, where are the CTRs, where are the TMAs. ATM Asterix, what is that? That is actually the Asterix is the data protocol that is used within the world of manned aviation to say where the manned aviation is. But most of the counter-drone systems also use that protocol and give information of where the illegal drones are. Then GIS data, weather, that is completely new in the drone world versus the manned aviation. And that really depends on the regulation of the country. There are laws that prohibit you from flying over natural parks. Well, you need to know where a natural park is. There are laws that prohibit you to fly over prisons. Well, you need to know where the prisons are, and so on and so forth. So a lot of GIS data that you need. The most complex one that we've seen is actually Germany. We have 25 different sets of data that we need to take into account to make sure that we are flying in a location that we need to be in. And then regulation, that's a technology that we've developed. It's we can take any regulations from a country or for a local location or a province and turn that in a database format so that we can start to do analysis on that. So with all that information, we can determine if a flight can be, is supposed to be, or if the drone is supposed to be at that location, we can do that before the flight, we can do that during the flight, and we can do that after the flight. And typically, the way that we communicate with the communities on the left side, we have a bunch of applications. We have a public map. Again, in a number of countries, we have an official map from the state, a dynamic map that shows where you can fly yea or nay. We have mobile applications for different models of mobile phones, where you can determine where you can fly yea or nay, or we can actually file your flight plan. And then web application with more sophisticated functions. And on the right side, we have a wide set of functions, on the one hand for national authorities, aviation authorities, but also for local authorities, the mayors and the police forces that want to know where drones are flying and where they are supposed to fly. One other thing that we did, tracking and remote ID. One of the things that really is important to know is where are the drones. Now, within the European projects, we've seen a number of, okay, my time is up. We've seen a number of tracking devices that didn't really work very well, so we created our own. Plus, what we also did with this new regulation, new regulation calls for an electronic ID, i.e. a form of license plate. This is the license plate for a drone. This is a small device, weighs 28 grams, sends out the electronic ID of the drone to any application that is ASTM compliant. Brand new on the market, it's fully independent of the type of drone, it's fully independent of the type of phone that you're using. And then just some examples of screens. This is, for instance, Belgium, where you have a dynamic map of zones where you cannot fly. The interesting part is the yellow part, and that's a part that is activated or deactivated with NOTAM. The fact that it is yellow means that a NOTAM has been created, and that zone will be operational within the next 24 hours. This is typically a screen that would be seen by the ANSP. It gets a list of all the requests for flight approvals, and at the bottom section you would see this is actually a flight plan that was created by a drone operator. And what the ANSP or the CAA sees is the exact details of where it is, the exact flight path, the ID of the drone, and so on. Flight tracking and tactical deconfliction, we have that as a standard function as well, where we can deconflict unmanned to unmanned, but also unmanned to manned, but also unmanned to no drone. So if a drone is getting too close to a no drone zone, all sorts of alarms go off. What is my conclusion? Every presentation has to have a conclusion. UTM can help take away drone anxiety, okay, which will propel the industry forward. It's only when the anxiety, we can take away the anxiety from a lot of people, that people will accept that drones will be flying in the airspace, and that's when we all start to make money. Thank you very much.